Boom. Hello, hello, 1 2 3 mic testing. Check. Hello, what's up? 1 2 3 1 2 3 check. Can I check now? Am I audible now? Hello. Hello. Yes, I am. Chill. So, what happened with me with my last exam is I fucked up. I could not finish the paper. I was not aware of my handwriting speed. Never had to take it into account. But the content what I studied for was like 10 on 10 I could write, but when I had to like physically put down it on the paper, I was fucking slow. And what happens when you are fucking slow? You cannot finish your paper in time. So the first question took me almost like 45 minutes. It was 5 questions that like weighted like 10 marks each for a 50-mark paper. I attempted 40. First question should get at least a 9 or a 10. The other ones, however, the second one right after that I wrote was not that good. So expecting somewhere around 8 or 7, lower 7s. Then after them it's like 8 and 8, 8 and 6. You're looking at like the average of like I'll probably get like 30 marks if like she's lenient enough, which is like fast. I did not write the whole paper, but still, bro, if I had written the whole paper, I could have been scoring at least 35 and above, which was my target for this paper. But fuck, bro, I hate that shit when it happens. So for that to not happen this time, I'm going to study harder. Not study harder, but study smarter. So, number one thing when it comes to weightage in paper distribution of like question distribution, the question pattern for each of the, what do you call it? Each of the papers are, I'm gonna break it down to you. Wait a sec. Let me put my cookies over there. And I'm consuming a whole lot of sugar in the morning because I need my brain to be functioning at maximum capacity, pure glucose, and like 1 sugary coffee latte. I used to drink pure coffee, but at the same time, I believe I don't use caffeine that much. So whenever I do use caffeine, it's kind of strong. I haven't developed a strong tolerance to it. So like a small, this thing just gives me enough power for like 2 hours at least. Keeps me awake, sharp, spidey senses tickling. Yeah, so it's like even I could dry shot, whatever the fuck it's called, like black coffee, terrible tasting without sugar. But I prefer this because it's tasty and it has more sugar and makes drinking coffee kind of pleasure, like kind of like good. Yeah, too many stress in this game. Anywho, moving on to the question paper pattern that I was going to talk about, and actually my game plan for the day is going to be, so starting with, we all know that the format is 10 mark of 5 questions, and of that the first 3 are unskippable, no skip. So if you don't know whatever is in there in the first, second or third, coincidentally has first unit content, second unit content and third unit content, if you do not know whatever is in there, you're basically cooked. You cannot skip it. But however, on the 4th and 5th, you have an option that either both of them would be from unit 2 and 3, right? So if you only have been studying unit 3, then you can at least answer this 4, this 3 because it's absolutely from unit 3, and 5 maybe. And there's an option between the both of them so that you can choose it, either if you want to go with unit 2 or 3. So unit 1 most of the time not much useful when it comes to weightage. Should not put too much time into it, I would say. Unit 2 probably the same amount as unit 3, but unit 3, why am I saying this putting this much emphasis about doing unit 3 is because number 1, wait, let me pull out my old question paper so that like I can like get a better understanding of this. Is because unit 3 has no full, it's like it's not the whole portion. It's only gonna be like 4 topics. So in a full paper for each of the subject we have 5 units, and unit 3 has half of it, like half of unit 3 is gonna come. The portion for the rest is literally 2.5. First unit, second unit, and half of third unit. So if you're going for purely content wise stuff, unit 3 is where it's at. And let's say how many slides in unit 3? Fucking 38. So my belief, I think it's only till KNN. KNN is a pretty hard topic. And yeah. Yeah. So to optimize my passing chances, I need that, yeah. A lot of story writing tomorrow is gonna happen, but I signed up for it. I like computer science, and I should not bitch about it now. Cheers. Good. The other ones were a lot more creamier, but Nescafe iced latte does the job. Fucking loved it. Alright. The paper here in my hand is what I wrote yesterday, and I'll go through the question pattern that they give. The first one was obviously from unit 1, which we all know I spent like around 1 hour 30 minutes according to the speedrun. Stupid choice, stupid decision by the way. Second is OSINT Open Intelligence, which I had to skip from unit 2 because godfuck I did not have enough time. Number 3 is system vulnerabilities. This one however I studied a lot. This is from unit 3. Social engineering pretext is from unit 2 again. They had an option by the way. I think we had an option, no? Or the process of footprinting or reconnaissance in ethical hacking, which is again unit 2, yeah. And last one was unit 3, which is CVE and CVSS, which we went through, and I demolished that question as well. Yeah, so pretty easy paper that I completely threw. This was a fucking throw. Sorry guys, but for me, I believe starting from unit 3 is a smart choice. We threw... yeah. Fuck. But anywho, it's 10 in the morning. This just getting started. I have an entire day of preparation in front of me. Hopefully I make good use of the time and have a banger examination tomorrow. And worst comes to worst, I just want enough marks to pass. That's about it. Fuck, where is my... Wait, let me get my pen and paper. Oh shit. Here we go again. Yeah, we'll just do some skim reading. What is machine learning? I have no idea, but wait, before that even, let me pull out the... What is it? Slide number 26. Slide number 26 on this, so doable. It's not that gonna be hard. Can I have my portion that I can like refer to? Syllabus, where's syllabus though? Another thing that I really wanted to talk about was I genuinely got a dream about getting an internship, not even a job. And that also, like, it was not even a paid internship. Is job market that cooked in the big 2026 that I'm getting dreams about like getting an unpaid internship? Wow. Mm. Eh. Shiba. Where is this class syllabus, bro? I cannot even find it. Not for ADMS, bro. Well. I cannot find out the... I cannot even find out the syllabus for some reason. I'm stupid. Huh? Well, if I check again and find it, I'm the biggest stupid fucking shit ever. This is all freestyle answers, bro. You cannot like mug up the answers and like vomit it on the paper, bro. You'll have to freestyle that shit, which I am very good at. But I cannot even find the PPTs. But fuck it, bro. I'll just read the PPTs and like not go through all that bullshit, bro. Whatever's in the PPT, whatever topics are there, I'm gonna study and be good with it. Good thing about the PPT is it starts from 4 and ends at 26, which means only 22 slides. Yeah. Let me have the other ones open as well. Unit 1 is at least, yep, everything is the equal distribution of 20 PPTs, which all of it's not that hard, like touch wood. And last key takeaway is not important, so average of that, let's say 18 on this one. PPT2 is preparation and reporting and research. Okay. Is whatever you understand you can write, so I kind of like these ones. Yeah, we're starting with the third one then. I think 1 and 2 would need, is like more theory based rather than like actual anything. Three has more weightage. As far as I'm concerned, 3 has more weightage. We're gonna start with 3. 3's everything is good. 3 knows that it gets some pussy all the time. Yeah, starting with Boom. Lazy learning. Unit 3, instance based and probabilistic classification. Okay. How do I open a new split? Can I have a new split? I can't. Yep. Now it's gonna be just unit 1, unit 3. And we started our split at exactly 30. The setup took like 30 minutes, bro. That's stupid. We saw. Lazy learning. Understanding nearest neighbor classification, measuring similarity. Okay. What is machine learning? Okay. Let's go. Machine learning is the handwriting rules. Instead of handwriting, we show the computer many examples and let it learn the pattern itself. Huh. Many examples and let it learn the
sleep.
Okay, the key differences between traditional programming, traditional and machine learning is number one, rules. In traditional programming, you have set rules for everything. Suppose in this example it says if weight is 150 grams and color is orange, label it orange. Fair. But it's a set rule, and anything that if the weight is less than 150 grams, it's not an orange. And if the weight is 150 grams above and the color is not orange, then it's not an orange. Fair. Good. But we do not want that. We want it to be different. How do we do that? We can have a machine learning model which we may show computer with many fruits of weight, color and the correct name. So we give them the label while giving them the training data. We'll tell, okay, this is orange, this is how it looks like, there's a correct label for it. Go through it as much times as possible, remember it. Next time I show you an example, you should be figuring out, oh, if it's an orange or not. You decide the rules. Okay, foundations of machine learning are supervised learning, unsupervised learning, and reinforcement. Very important. Let me just write it down.
Sleep.
Question. I think I'll write down the answer after I've understood the stuff. Supervised learning, data comes with correct answers, labels. The model learns to map input to output. Fair. In the above example where the fruit weight was given and the fruit color was given, the fruit name is given, we were able to predict the fruit name. We were able to give it its proper labeling. However, on the second one, unsupervised learning, no labels were given. The model finds natural structure or groups in its own. Example, grouping fruits by similarity, no names given. Okay. Reinforcement learning, an agent learns by trial and error, guided by rewards and penalties. Reinforcement learning is how you probably train your pet to do something like give it a handshake. So it's very easy to remember. Yeah, it's nothing new. I think I have already studied about this a bajillion fucking different times, but writing this in a 10-mark question answer type basis in an exam where I'm stressed, I might make some mistakes. So, but besides that, this is free, bro. Supervised versus unsupervised. Same fruits, two different problems. Supervised, labels included. Unsupervised, no labels. The model learns from the fruit column, then predicts the name of a brand new fruit. This is classification. Okay. No fruit column exists. The model just groups similar looking fruits together. It never learns their names. This is clustering.
His biological dad walked out of his life when he was 6 months old.
Basically, I go get high and then I come back and then fight with my stepdad.
He had punched my husband, and he had also punched me in the head.
He's a big kid, man. He's 6'1", 235 pounds. And he outweighs me by at least 50, 60 pounds.
To supervise tasks, classification and versus regression. Classification predicts a category class label. Regression predicts a continuous number. Is this fruit an apple, orange, or lemon? Okay. Output a label from 6 set of classes. Canine is used here. Our focus today. Nice.
That's not good to have law enforcement know you in that site. You know that?
I'm on my last cookie. I'll finish this cookie and get back to studying. I don't think I can like take one sip, eat one cookie, and move on. Like, I don't think that's happening. Okay, I'm fully fed now. Time to lock in. Alright, bro. Lock in, lock in. What happened? Alright. Classification versus regression. Classification predicts a category label, class label. Is this a fruit, apple, or lemon? Output obviously gives a label from a fixed set of classes. Because we are training the data set on labels, we already know the training data, whatever we have given, is going to be either apple, orange, or lemon. So it already knows what out of the 3 classes to pick. And output is from a fixed set of classes. Regression, on the other hand, was feeding the data and we are asking it questions that are outside of its label that require continuous numbers instead. It inputs a continuous number, such as here is saying how much this fruit will weigh in 3 more days of ripening, which obviously when fruits ripen, not only their color changes, their weight changes as well, even it's small. We're asking the question and it might calculate, okay, this is pre-ripe, this is post-ripe, this is how much data it'll compare and like, or give us a average value. I don't know how this magic works, but it'll give us this value to go off of. Obviously this value is not in the training data, just so we know, we not have any labels for any of the data here. It just gives you a continuous numeric value and it predicts. So regression. Here classification is oftentimes it just gives you a label that is already there from a set fixed like number of labels that you have given in your training data set. On the other hand, regression, however, does not have all of those labels, so it'll give a continuous number based on what you're asking, or based on what you are training this model on and for. Yeah. Holy shit. Vocabulary, nice. Key terms you'll need. Vocabulary is a very important. Thank God whoever created this PPT definitely knows what's up, because oftentimes when I'm trying to read something, it's a huge problem for me because I do not know the like proper terms that is used in the industry. Sometimes they'll have, oh, what's a tuple? I have no fucking idea. For example, I do know what a tuple is. It's a row. But first time seeing it and they reference it multiple times throughout the text, I have no idea what they're talking about. So yeah, having this section of the PPT really is a big help. Thank you for whoever created. Shout out to Mrs. Krishna ma'am who made this PPT probably. Shout out, big shout out. Very good teacher. Top 10 teachers of all time. Instance sample, 1 row of data, 1 fruit with all its measurements. Okay. Yeah. So 1 row of data would be like, oh, the fruit apple, for example, have like 3 columns each. 1 row of data would contain, oh, apple's weight, apple's color, apple's label. I don't know. The label we already know, but other factors, sweetness, tastes, smell, I don't know, you could add more if you can, however, have a quantifiable way of measuring all of those quantities for each of the columns. I don't know how it works, but yeah, you see, weight, sweetness, color, yeah, I'm him. So the instance of a sample is 1 row of data for each of the measurements for each fruit. Feature or attribute is measurement used to describe. So what are the features of an apple? Its weight, its color, its shape, so on and so forth. Where label and class, the correct answer we want to predict. Oftentimes, if we have weight to be more than 150 grams, sweetness is slightly sweet and acidic, kind of. And the color is red, we'll predict apple. Apple here is our label or class. Nice. Training set, the fruits we already know the correct names of. Nice. That's set. New fruits whose names we want the model to predict. Nice. Lazy learning classification using nearest neighbors. Lazy learners. Instance based. Instance is one row of data. Nice. I still remember this. Instance-based learners do not build an abstracted model during training. Instead, they store the training examples verbatim. Verbatim, I think, means here as it is. They store the training data as it is and only work when a new unlabeled example must be classified. This is to contrast eager learners like decision trees, which generalize beyond the training data during a distinct training phase before any predictions are made.
On second thought, never mind. Things came up.
So what's your take?
My take is there should not be examinations where you could just memorize and just put the information there. Just have more understandable information, knowledge testing examinations instead. Yeah, that's my take. Wait a second, I need to know something. If you Steam game nice. Nice. W. Lazy learners are instinct-based algorithms that do not build a model during training. Instead, they install all of the training examples and wait until new data point arrives. Only then they do perform the computation needed to make a decision. Lazy learner KNN, you do not study beforehand. Instead, you keep all of the textbooks and notes. During the exam, whenever you see a question, you search through your notes to find the most similar example. Then you copy the answer based on the similar examples. Okay. Eager learner. Read everything, make a summary or cheat sheet in your mind. During exam, you answer quickly because you already learn the pattern. This is how decision trees work. Okay. Okay. Learning happens during prediction, which is like you just predicted it. If it's correct, then good. Lazy learning prediction is slow because learning is happening right when you predict, but no training time. KNN is a lazy learner. Eager learner is builds a model, obviously. Training takes time. Prediction is fast because you have already made the decision tree. And example, like prediction, boom, you already know what's that, so you can predict quick. Training takes time, builds a model. Yeah. Study in advance. Eager learning. Lazy learning, studying during the exam, which is I think I'm a lazy learner, so yeah, fair. Fairs. How it works: store all training data, receive a new sample, compare with the stored examples, predict based on more similar cases. This is a new point, new test instance. This is a new test instance because we are giving the new training data where it has height and weight. Height being 172 and weight being 68. 72 is nearer to this sample and this sample and this sample. kg weight is also near this, and also if you want to push it here as well. But now that we have all of these samples, we can see that okay, this is our fit class, this is also fit, this is unfit, but due to majority voting for k neighbors, which is 3 here, 2 out of 3 says that it's fit. That means the majority vote is fit. You can also have k number of nearest neighbors. You can tweak the value of k, go up and down, so that you'll have a more accurate result or less accurate result based on whatever you're trying to see. I think having 3 is a perfect balance of, having in a data set like this. 3 makes sense because it's more compact, so it's less error for shit to go wrong. If k value increases too much, there's too much randomness increase. If k value is too less, then bias is introduced, which is good, which is bad, definitely bad. You are a cyber student? Someone texted. No, I'm not cyber student. Yeah, kind of. Yesterday I was studying cybersecurity, not today. Shit, I forgot almost read the chat. Currently I'm preparing for my exam tomorrow, which is machine learning. Research using machine learning. My midterms are coming up, that's why. But yeah, I do occasionally, try to dabble in a little bit of cybersecurity from time to time. Shit, I should have a chart counter or whatnot. I keep missing charts, bro. My bad, bro. Whoever it was, they already left. Yeah. Alright, bro. Moving on to the next one. Advantage is very simple. No training time, can adapt easily when new data is added. It's good for small databases. I think it is for lazy learners, right? Very simple, obviously. No training time, can adapt easily when new data is introduced or added. Small for good. Good for small databases. Holy shit. Disadvantages: prediction is slow, requires storing all data, memory intensive, performance decreases with very large data sets. Applications: recommendation systems, pattern recognition, medical diagnosis, face recognition, handwriting recognition. Okay, for lazy learners, right? Yeah. Prediction is very slow. Requires storing of all training data, which is bad when you have a huge data set. It does not really work. It requires memory intensive, since obviously you are going through multiple data set, all instances of your data set to calculate it real time. Learning is definitely happening in real time, so yeah, I can see why it takes a lot of memory. Performance decreases with very large dataset. No shit, Sherlock. Applications: recommendation systems, pattern recognition, medical diagnosis, face recognition, Handwriting recognition. Recommendation systems. Yeah, fair. If I like this one, I like that one. Almost no requiring of training is done. It just calculates, oh, you like this one, you like that one, we'll recommend you this video. Makes sense. Pattern recognition, same as this. Medical diagnosis. Symptoms are closer to this. Patients weight is this, patients like this. You can compare all of those features. Yeah, I can see why Kane and Cat could work on this, but again, I would not rely heavily on medical diagnosis by an AI. I do prefer the human touch. Sorry guys. Handwriting recognition. Handwriting recognition. His handwritings are closer to this. He likes to curl his L's, and instead of dots he uses small circles for I's and J's. Yeah, I can see how it can work as well. Yeah, fair. K-NN fundamentals, the nearest k-neighbors algorithm. K-NN treats features as coordinates in multi-dimensional feature space. Bro, that's a mouthful, bro. K-NN treats features as coordinates in a multi-dimensional feature space. There's some Iron Man shit going on, okay. K-NN treats features as coordinates in a multi-dimensional feature space. What the fuck that actually means? Every label training example becomes a point in that space. Hold on. Yeah, properties of an object, however object looks, how an object is, what an object, all its characteristics. Weight is a feature, sweetness is another feature, yes. Treat these features as coordinates. Think back to school math. A point in a graph has coordinates, yes. Okay. Okay. Each fruit now is just a point. Suppose your training data set is... So that's why y equals mxc works, because it's just points on a multi-dimensional plane. Holy shit. I actually knew that, but never actually... Well, actually I have visualized it, like to go like this, but yeah. Every time I try to learn, this bitch always comes up every fucking single way. I see him everywhere, bro. K, so y equals mx plus c, bro. Slope just pulls his ass out like whatever possible. Makes sense. It's a multi-dimensional graph because it's easy to show it in a 2D paper, 2D piece of paper. Sorry, 3D, yeah, 2D piece of paper because it's a 2D this thing. You cannot really show 3D here, but multiple dimensions do exist. If there are 10 features, it will be a 10D graph. which is what I like about computers, is because they can see their bullshits. I like this explanation. Oh, this is where it gets tough. Huh. Wow. Yay. Why the fuck is Matt involved here? No! Bro, I'm getting the coffee shits. I'm getting the coffee shits. What should I do? Should I push through it? Probably, yeah. Oh, I can leave the stream running and go shit. Come back. Be more refreshed. Oh, I could like push through like RLS, bro. How do I pause? I forgot how do I pause. Boom. Yeah. Shit is paused. Now I shall go shit and come back. So far, I like this unit. Very easy. Very good. Me likey. Plus, it's only 20 pages per PPT, which is like insane, bro. So informative. Love it, bro. I must go take a shit, come back. Yeah. I think all of my viewers be like, ew, he's shitting. Might as well go back. What the fuck is my... Not interested. Do I need to take a shit or is just phantom shits? Let me go try out shitting first and then we'll see. I'll close the camera while I'm going. I think the stream on is like very scary though. Like, what if I flash myself? I'll get banned on YouTube. Boom.
This is going to be such an exciting day. I hope you enjoy it. I think you will. life, there are no words. We are the dreamers of dreams. If the good Lord had intended us to walk, he wouldn't have invented roller skates.
Hey bro, I'm back. Bro, that shit genuinely took like 5 hours of my life. I need to be eating more fiber, bro. I swear to God. Holy shit, that was bad. God damn it. Alright, bro. I'm gonna put it in the bag. Back to basics. Alright. How does Kanan work?
I was wondering if maybe you'd like to go to the beach and maybe get a coffee after or something, if that's alright.
See, I might be cooked depending on what comes tomorrow, so yeah. Not looking good for me. But starting with, I think the lazy learning I'm done. K-nearest fundamentals. How does it work? The k-nearest neighbors algorithm treats features as coordinates in a multi-dimensional space. Every label training becomes a point in that space. Every label training example becomes a point in that space. We have seen that here in this graph example, where every training example is a point in this graph. Currently there's 2 features, so it's a 2D graph. If there were 10 features, it would be in a 10-dimensional graph, which is crazy. 2D is more easier to represent on a piece of paper and a plane. Like it's the simplest form. 1D is the most simplest form there, but 2D also works. Complex enough so that we'll have the X and Y. Anyways, that's how it does. Select. Good. Yeah, I'm using my phone again, bro. This is not good. Ash, so how does it work? Working off KNM. Place all labeled training examples points in n-dimensional feature space. This is sick. Obviously. Plotting and placing all labeled training examples as points in an n-dimensional feature space. That sounds like an intro to a Vsauce video, but yeah. Locate. Okay, plan a plot, locate, measure, select K and vote. Okay. Locate for a new unlabeled example, computes its position in the same space. Measure the distance. Identify the key training examples that are the closest to the nearest neighbors. Assign new example class held by the majority of its key neighbors. Okay, fine. Makes sense. Plot. Locate. Measure. Select K. Vote. Pretty simple. LPMSV. PLMSV. Plot, locate, measure, select K and vote. Starting with plot. As points in feature space. Compute its position. Measure distance from itself to every other point. Error closes. CNN. KNN makes no assumption about the underlying distribution of the data. It is a non-parametric method that lets the data speak for itself. So, it's like my chess speaks for itself by what was the guy who cheated? Niall Henson or something, bro. The butt plug chess cheater. Yeah. Fuck it, bro. Continuing on. Case simply the number of nearest neighbors considered. Okay, fine. Training data. Okay. Lance machine learning with R introduces KNN through the task of identifying malignant and benign samples and breast cancer. Yes, sir.
By the way, I feel bad. I never asked you how your love life is going.
No. As you know, that was a done deal long ago.
Model tuning, choosing an appropriate k. The choice of k determines how well the model generates Generalizes to future and unseen data. It governs the balance between overfitting and underfitting. Very small k allows noisy, unrepresentative points outliers to unduly influence the classification.
I'll get straight to the point. I found marijuana in the house. And while I never thought of myself as the type of father who'd have to drug test his kids, I'm willing to do just that if that's what it takes.
Small
to find
K
out who brought
here.
a joint into this house.
Dad, Lucy found something too.
Dad, I found a joint in Mom's dresser drawer.
Okay, we're talking about outliers. When you talk about noisy, we're talking about outliers. So number one would be very small key allows noisy or unrepresentative data points outliers to influence classification. Noisy or outliers are there influence the classification. Model becomes complex and captures idiosyncrasies of training data. What the fuck is that? Measurement error. Okay. Outliers or measurement errors, let's say, for a very small k, and the risk is overfitting, low bias, and high variance. I can answer new questions. Overfitting should memorize every question exactly. If diagram changes slightly, they fail. Okay. Similarly, k and k equal 1 memorizes tiny details and noise in the training data instead of learning the overall pattern. This is called overfitting. Low bias, high variance. Bias means how much does the model oversimplify reality. Low bias means model is very flexible, it can fit almost everything. Variance means how do prediction change if training data changes slightly. Now the answer becomes model is too simple. High bias, low variance. The model changes very little even if the data changes. Okay, so low variance, but it oversimplifies everything. High bias. Choosing the right key. Give me examples. of low variance and high bias, and how underfitting. Low bias model with high bias is too simple. Assumes every data follows a basic pattern and ignores important details. Okay. Low bias. Okay. Training accuracy becomes much better because low bias is generally good. If taken too far, it can lead to overfitting. Low bias can learn everything. Too enough learn complicated relationship. High bias means it's too biased and the model becomes too simple and strict, and the model becomes too simple and like is biased because I'll just use this one fucking formula that like and ignore every other small features that you have got going. Yeah, low bias is like more open. It's not like bias. It's like arguing with LGTB, TPQ, RSTU, WXYZ, TV, HD, TV, 4K, and arguing with someone who is open to new ideas. High bias, I cannot change. They have one thought process, they are stupid and think, bro, I'm gonna get cancelled. Fuck. But you get the point. It's like arguing with someone who is very up his ass and is not willing to change. They are not going to change whatever you do. They're very different to change, and yeah, they don't understand jack shit. You cannot change them. You cannot fix her. On the other hand, low bias is more like, okay, I admit to not knowing everything, but I'm open to learning. So that person can grasp other, instead of looking at only okay this equals this and that and the small picture, they look at the whole picture and be like, okay, I'm more open to learning about this small relationships that overall help me also calculate the big picture. Yeah, I think that's a stupid explanation, but that's easy enough so that I can remember in school and like I can remember it in exam and write. It does the job. It's simple and this will stick. So low bias and high variance would be underfitting. No? Overfitting. Fuck. Low bias is overfitting? Yeah, taken too far, it can be led to overfitting. High variance. Variance measures how much a model changes over when the training data changes slightly. High variance memorizes everything instead of learning general patterns. Because if memory is not understood, this is exactly what an overfitted model does. Machine learning example. Free money. Okay. Meeting tomorrow. Not spam. Prediction. Okay. Okay. Training data. App. Low variance model gives similar predictions even if the training data changes slightly. Training data set 1, apple, orange, apple, lemon. Training data set 2, apple, orange, apple, lemon, apple. Prediction remain almost the same. The model is stable. Real life examples is self-driving cars. Training images, sunny weather. Okay, now it says rain prediction, road not detected. Tiny changes confuse it. High variance, okay. Okay. Nearest neighbor is orange, prediction is orange. Now imagine that the one orange was removed from the dataset. This small change completely changed the prediction. This high variance, which is not good. It should be medium bias and medium variance. Okay, perfect. Low bias and high variance is underfitting. Low variance is high bias is overfitting. Oh no. Low bias and high variance is overfitting. That's for small k. High bias and low variance is underfitting. Large k. Smooths out influence of individual points, including relevant ones. The classifier may lean towards overall majority class, ignoring local structure. Okay. High bias cannot memorize data. Okay, training accuracy low, very high, but it memorizes data. So, underfitting, overfitting. Example: house prices by using only size, memorizing every email instead of learning spam patterns. High bias oversimplifies, high variance memorizes. Okay. Damn. Alright, bro, that's crazy. Data preparation, preparing data for use with KNN. As KNN directly relies on distance, features must be placed on comparable scales for test training. Otherwise, features with larger ranges dominate the distance calculation. K is a hyperparameter you choose before running the algorithm. More on this next. K small, overfitting. K3 to 5 if you have a sample size of, let's say, at least 25. Square root of 25 is 5. Very good K. K too large, it's underfitting. Okay. Use an odd value of K in binary classification to avoid bad scores. Fair. Okay, instead of it being 0 to, okay, so makes sense. Now every feature contributes fairly to the distance of calculation based on its actual relevance, not its unit of measurements. Oh, okay, scaling is important. Strengths, weaknesses. Simple to understand and implement, no training phase, instant to update as you go. Like as you implement the model, it trains, and like it's simple and like good and everything, and like is him. Naturally handles multi-class problems, works well with small clean datasets, slow at prediction time on large datasets, sensitive to relevant or unscaled features, struggles with high dimensional data, needs enough memory to store all training data. Okay. Data preparation is wait, let me write down my notes. Data preparation. Bro, I'm getting spam calls left and right, bro. Order some food, bro. Yeah, maybe now I'll end it. Seems like I'm good enough. Any methods to automatically determine the serial value of k? Starting, we should always start with the square root of k. Square root of or training samples. If our training samples have at least 25 samples, so square root of 25 equals to 5. So k equals 5. Starting value of k being 5 would be a good starting point. We will increase or decrease the k values depending on how well it does on the validation testing. And from that we'll choose the best. Can KNN perform well with a dataset which is having missing values and noise? KNN can KNN perform well with a dataset which is having missing values and noise? Missing values and noise. Noise would be outliers, noise would be values that are not accurate. Missing values, not really. KNN will fail to perform at its peak because it will get influenced by the missing values and the noise, because depends on K. Yeah, I would say it will not work very well. It heavily relies on its neighbors and all the values. One of its key strong suits is plotting everything on an n-dimensional plane, all the end points and features. So if you have a lot of noise and missing values, finding the no matter how many K neighbors you have, even if you find the most optimal one, there are still missing values that might influence, and that outliers and missing values that will not allow KNN to work at its peak performance. How do we know which variant of KNN is best before testing? The default variant of KNN uses Euclidean distance. You can also, alternate way of testing is also this thing. What do you call Euclidean distance and Manhattan distance? Which variant of KNN is best for testing? We can buy, I don't know actually. Let's see. Yes. Final answer, KNN does not perform well. Okay, fair. There's no way to know beforehand. Yes, each dataset behaves differently. Let's see, KNN, weighted KNN, different metrics. Yes. Influence. Type of data, number of features, presence of noise, division of data. Compare the performance. Lazy learning. Lazy learning stores already in training data and answers as you go, and without building a proper model. Learning only happens when a new training data example or new instance needs to be classified. KNN is an example of a lazy learner. Yes, is lazy learner because no computation is used during training. It waits until the prediction time to calculate distances and classify new instances. As an instance, instance is a row of data in a dataset. What is a feature? Features are columns or measurable properties or attributes of your test subjects or your data, such as weight or sweetness of an apple. What's label? Label is the correct class to which all the features belong to, and the model tries to predict. What does k represent in KNN? K represents the number of nearest neighbors. What happens k equals to 1? Overfitting. K too small, overfitting. Low bias, high variance model is too simple, and low variance, high variance means it just memorizes everything. Low bias means the model is too simple. K too large is underfitting. Model too complex. Yeah. Ignores local patterns and may predict majority class. Square root of n, where n is the number of training samples. Card 11, which distance is the most commonly used? Euclidean distance. Euclidean and Manhattan, which is feature scaling important in, yes, it is important, distance calculation. Features with larger numerical dominated distance if data is not scaled properly. So normalization, min-max normalization should be used. There's Z or Z score standardization. Min-max normalization is what I prefer. Technique with scales converts values into 0 and 1 range. No rank is to implement. Okay. Underfitting. The model is too simple and learns. Okay. It was an eager learner. Eager learner is a model that builds the model, trains on it specifically, and gives very fast answers. For example, decision trees. KNN. Decision tree, I know. Because it measures numerical distances, so categorical distance features must be converted using dummy coding. KNN is classified as a lazy learner. K number of nearest neighbors, which Euclidean. Usually, very small k is overfitting, underfitting. Normalization, min-max normalization, dummy coding, decision tree. KNN builds a model during training. False. KNN stores all the training examples. True. Euclidean distance measures straight line distance. True. Manhattan. True. False. False. True. Builds model. Does not build model. Training time it learns. Learning only happens in training. Because of huge values that might tilt to their favor, and thus values that have less range or smaller values might not have huge weightage in the final decision making. What is the purpose of choosing an appropriate k? Choosing appropriate k should be, you should start with the value of n square root of n, where n means an n number of testing samples, and you should go up or down depending on which gives you the most appropriate results on your validation testing. Validation testing results. State one advantage and disadvantage of KNN. KNN advantage is almost no training time. Training only happens when you run the model prediction. Disadvantage is the results are very slow, and also number 2 is a lot of memory is required because it stores everything as it is and only predicts whenever. The difference with overfitting and underfitting. Overfitting is when the model does exceptionally well in training, but when introduced to a new set of data, new unseen data, it performs horribly. It does not learn the overall pattern but gets distracted by the small irrelevant patterns, learns them, and that's why it performs poorly. On the other hand, underfitting would be the model is way too simple and it just gives the same result for every single one and gives irrelevant answers because it hasn't learned any of the local patterns, any of the large patterns. It just learns the local patterns and just gives answers based on it.
Always buy Chesterfield, the milder cigarette. And Chesterfield leaves a clean, fresh taste in your mouth.
Where is it? Yep. My food is almost here. Predicts school based on the attendance based justify answer by okay. Working. Collect historical student data. Each student becomes a training instance. Features may include attendance percentage, previous examination marks, label pass or fail. When a new student's data is entered, Kane calculates the distance between new student and previous student. It selects Kane nearest neighbors, majority class among the neighbors become the prediction. Easy to implement. Fine. Scenario based. Okay. Either selected using validation or cross validation comparison. Okay. Application. Predict whether a person at high risk of heart disease using age, blood pressure, cholesterol, and BMI. Because KNN, because it's a classification problem. Okay. High risk or low risk. Yep, I think we are done here. Our first split, and I also need to pee, so I shall end the stream very quick now here. Thank you everyone who all are watching. Yes, thanks for sticking around, and we will see again each other after I eat my food, chill a bit, probably game towards the end of the night. So that's about it. Thank you very much for sticking around, and whoever was in the chat. Until next time, see you. Bye bye. Unit 1 is completed. I shall complete unit 2 and 3. The first unit took us 1 hour 46 minutes, which is fuck, bro. So yeah, cheers, bye bye, and see you next time. Peace.